Hello students, today we'll learn how to find out the magnitude of force of friction. Next, at what time we'll apply static friction, at what time we'll apply kinetic friction, and the minimum force required to move a body in a frictional surface. So let's start. Before going to start doing any problem related to friction, let me give you a brief understanding of the force of friction, correct? What we know, when a body is not moving but a force acting on it, the force of friction which comes into account is static friction. And when the body is in a position due to the application of the force applied on the body is about to slide over the plane, but it is not sliding, but it is about to slide, correct? So at that particular point of case, what we write, frictional force is limiting, that is the maximum value of the static friction, and which is directly proportional to normal reaction, and we can write Fs maximum is equal to mu s n, where mu s is called coefficient of limiting friction, and what we know, it is the maximum value of the static friction. That means up to this value, static friction is self-adjustable. It is equal to the applied force, correct? Net applied force. So what we can write, if static is less than equal to Fs maximum, or Fs is less than equal to mu s n. So please keep it in mind, when only the body is about to slide, then only apply this formula, otherwise not. Clear? If the body is applied, means because of the application of the force, body is not sliding, that means frictional force which is acting on the surface in contact is static friction. And if the body is not moving but about to slide, so we'll consider that as a limiting friction. But when the body starts moving because of the applied force and body is moving, at that particular point of time, the force of friction which will come into account is kinetic friction, and we'll write it Fk equal to mu k into n. I think you people are quite aware about this. Mu k is less than mu s. So this is the basic understanding with the help of which we can start the lecture. Okay. Now look at this, students. The question is given like this. A body of mass 2 kg is placed on this frictional surface. It is acted upon by a force of 2.5 Newton. So find the value of the frictional force. Now, first I have to check whether the body is moving or not, correct? So first we have to check, because of this 2.5 Newton force, what is the frictional force acting on this 2 kg mass, correct? So what to do? Your task is to first find out the normal reaction. So what to do? It's a plane surface and mg acting downward, that is 2g, which is equal to 20 Newton is acting downward, and normal reaction is acting upward, and frictional force is acting on this direction between 2 kg and this. Means this is a fixed surface. I'm going to find out the force of friction on the 2 kg mass, correct? Check what is the value of F, correct? How to check it? Look at this step. First, find out the value of the limiting friction. So what is the value of Fs maximum? Just at the beginning of the lecture, I told you that formula, mu s into normal reaction. Now, what is mu s? It is 0.4. What is the normal reaction? It is 20. So if I calculate this is equal to 8 Newton. Now look at this. What we know, static friction is self-adjustable up to the limiting value. That means static friction is equal to the applied force up to the limiting value, correct? Now look at this. In this case, the force which is acting on the body is only 2.5 Newton, but the force of limiting friction is 8 Newton. That means this friction can increase up to 8 Newton with the applied force. Clear? So the force acting on the body is 2.5 Newton on this body, And in order to keep the body at rest, the force which is required at this position is only 2.5 Newton, not more than that. So in this case, F is acting is 2.5 Newton is the static friction and acting in this direction. So this is the first problem, and this is the technique of solving this. Let's do another problem. Look at this, students. The problem is given like this. Two forces, 4 Newton and acting 3 Newton, are acting on a 2 kg mass perpendicularly. Okay, and the surface of the board is actually the surface on which the body is placed. Here we need to find out the value of the force of friction as well as the direction of the force of friction. Correct? So what to do? First of all, let's start solving this sum in this manner. First, find out the resultant of these two forces. Correct? For resultant, I'm doing one thing. I'm just extending this line. So look at this. The 4 Newton force is acting along this direction and 3 Newton force is acting along this direction. This is 90 degrees. So what would be the value of the resultant force? Obviously that would be equal to the resultant of these two, and this would be acting along this direction. Clear? So what would be that? Root over of 3 square plus 4 square, which is equal to 5 Newton. Now, if we calculate the value of the limiting friction in this case, so Fs equal to mu into normal reaction. Mu is 0.4 and normal reaction is like previous one, 20. That is 8 Newton. But the resultant force acting on the body is only 5 Newton. So obviously, the force of friction that will act along this direction, always remember, the force of friction always acts opposite to the direction of the resultant force in this case. Correct? So in this case, the answer would be only 5 Newton, but the direction of force of friction is this. Okay? Now let's solve another problem. Look at this, students. A problem is given like this. There is an inclined plane of angle of inclination 37 degrees. As 12 kg mass is resting on this. Okay, 5 Newton force acting on it. So you have to find out the value of the force of friction. Keep it in mind, the body is resting on the incline. You have to find out the value of the force of friction. So what to do here first? Correct. So let me solve it like this. First of all, the force which is acting along the incline. Obviously, what we know, this is equal to mg sine of 37 degree. What is m? This is 12. What is g? 10. And what is the value of sine 37? It is 3 by 5. So let me calculate this. For 12 into 2, 24. 24 into 3 is 72 Newton. Clear? So 72 Newton force is acting along this direction. 5 Newton force is acting along this direction. Now, if I draw this, so look at this. This is 72 Newton and 5 Newton. Both are acting perpendicular to each other. So what will be the direction of the resultant force? This. So frictional force would be acting along this direction. And what is the value of that frictional force? F equal to root over of, that is 5 square plus 72 whole square. Okay. So this is the answer. Now, let me solve more problem related to the contact force of friction, so we can understand the concept in a much better way. Correct? Look, students, a problem is given like this. A force F is acting on this block, making an angle of 30 degrees with the horizontal. We need to find out the value of F for which the body will just begin to slide over the surface of the horizontal plane. Coefficient of limiting friction is given mu is equal to 0.25. So what to do in this case? First, split this force into two components. One parallel to the surface, another is perpendicular to the surface. So if I do this, so what will I get? This is equal to F cos 30 and this is equal to F sin of 30. Now look at this. In this case, it is given, you need to find out the value of F for which the body just begin to slide. Correct? That means it is begin to slide. That means it is not still accelerating. Correct? That means look at this very, very carefully. F cos 30 is acting along this direction. F sin 30 is acting along this direction. Now let us try to find out the value of the frictional force. Mg along this direction, normal direction along this direction. What is the value of mg? That is 100 Newton. Clear? Now, let me do one thing. First, since in this direction, there is no net force is 0. So what we can write? N equal to mg plus F sine of 30. What is mg? That is 100. F, what is sine 30? That is half. That is 100 plus F by 2. Now, body just begin to slide. That means in this case, the force of limiting friction will act and that will act along this direction. Tendency of motion is along this direction. So force of friction will act along this direction. But in this case, this is Fs maximum. So what we can write in this case, look very carefully. In this case, since this body is about to slide, that means Fx maximum just balance this component of force. That means what we can write, F cos 30 is equal to Fs maximum. Now F cos 30 is what? F into root 3 by 2. Fs maximum is what? Mu s into normal reaction. Now F into root 3 by 2. Mu s is what? Mu s is given 0.25 and normal reaction is 100 plus F by. Now if I do the calculation, this is equal to root 3F divided by 2 equal to 0.25 means 0.25 into 100 is 25 plus 0.25 means 25 by 100, that is 1 by 4, that means F by 8. So if I do the calculation and take it on that side, so what will be the value? Root 3F by 2 minus F by 8 is equal to 25. Now if I simplify this, so this would be equal to F root 3 by 2 minus 1 by 8 is equal to 25. Therefore, F equal to, that is equal to 25 into 8 multiplied by 4 root 3 minus 1 Newton, which is equal to approximately 33.73 Newton. So let's solve few more problems related to this. Look, students, the problem is given like this. A block 5 kg is resting on a rough plane. Okay. The coefficient of limiting friction between the block and the surface is given 0.6 and coefficient of kinetic friction between the block and the surface is given 0.5. Now we need to calculate the force of friction where force is 5 Newton, when force is 25 Newton, and when the force is 50 Newton. So let's start solving the problem by finding the value of the normal reaction. This is equal to M into G is equal to N. Now, when the force will act on it, obviously the force of friction will act on the opposite direction. Now, confusion may arise ki what kind of force of friction will act. So, I will check it later on. First, let me calculate the value of the limiting friction. So, what is the value of Fs max? That is equal to mu s into normal reaction. Now, in this case, mu s normal reaction is mg. Mg means in this case, look at this, mu s is given 0.6, m is given 5, g is 10. So if I do the calculation, it is equal to 30 Newton. Now, one by one. If F equal to 5 Newton. If F equal to 5 Newton, that means the applied force is much below the level of limiting friction, correct? And what we know, the static friction is self-adjustable up to the limiting value. So in this case, what will happen? The force of friction will be 5 Newton only in opposite direction. Okay. Now, if I consider the second case. Now, in case of if I choose the second case, that is 25 Newton. Look at this. If I choose 25 Newton even, it is 30 Newton. Watch it carefully. Correct? That means this force is also below this. Clear? So if I do the calculation for this also, so what will happen? 25 Newton is less than this. So in this case, F is 25 Newton. So limiting friction is 30 Newton. So the applied force of friction is equal to applied force, which is equal to 25 Newton. But what will happen if the value of the applied force is 50 Newton? Look, it is the value of the limiting friction, and it is much higher than the value of the limiting friction. So body in this case will be in what stage? It will be in state of motion, correct? So what frictional force will come into action? It will be the kinetic friction. So in this case, F equal to, will apply mu k into normal reaction. Look, mu k is what? Mu k is given, that is 0.5. And what is the value of the normal reaction? That is 5 into 10. That means this is 25 Newton. Now the confusion may arise here. How it is possible? In this case, it is 30 Newton, it is 25 Newton. I told you earlier, once the body comes in motion, the body will be under the control of kinetic friction, and that is less than the limiting friction, because inertia plays an important role in this case. In case of up to limiting friction, inertia opposes the applied force, and in case of kinetic friction, inertia supports the motion. That is why this happens. Okay. Look at this, students. A problem is given like this. A force of 50 Newton acting on a block, making an angle 37 degree with the horizontal. Mu s between the block and the surface is given 0.3, and mu k is given. You need to calculate the acceleration. So before going to calculate, we have to check what kind of force of friction will act, correct? So for that, what you have to do, we have to split this into two components. So what will be the value of this? This is 50 cos 37. So we can write Fx equal to 50 cos 37 degree, and that is equal to 4 by 5, and which is nothing but 40 Newton. What will be the value of this portion? This will be equal to 50 sine 37, and y component will be what? 50 sine 37 is 3 by 5, and this is equal to 30 Newton. Now 30 kg mass, 3 kg mass, so 30 Newton force acting downward, and the normal reaction acting is upward M. So let's start doing the calculation for limiting friction, correct? So let's start it from this. A should be equal to 30 plus 30, that is 60 Newton. Okay, what will be the value of the limiting friction? Fs equal to mu s into normal reaction, and mu s is what? That is 0.3 given. Normal reaction is 60, that is only 80 Newton. Now, what is the value of the force which is acting on this direction? That is 50 cos 37. That means x component of force is 40 Newton, which is much greater than the value of the limiting friction. Correct? That means what we can write, that means Fx is greater than Fs maximum. Fs maximum. So in this case, obviously the body will slide. And if the body will slide, the force of friction which comes into account is the kinetic friction. Clear? So in this case, the force of friction which acts on the body could be kinetic friction, and that will be acting along this direction. What is the value of Fk? Fk equal to mu s mu k into normal reaction, which is equal to mu k equal to given 0.25. Normal reaction is 60, and that is equal to 1 by 4 into this, that is 50 Newton. Now, so obviously the force which is acting towards the positive x-axis is more than the force which is acting towards the negative x-axis, correct? Because in this case, the kinetic friction which is acting is what? Look at this, that is equal to 15 Newton, correct? So what to do? Find out in this way. Look at this, Fx minus Fk equal to mass Fs, my Fx minus Fk equal to mass into acceleration. What is the value of Fx? 40. What is the value of Fk? 15. What is the mass of the body? 3 is this. 40 minus 15 is 25 by 3. It will supposed to be 8.33 meter per second square. Look, students, a problem is given like this. A force F is acting on the block making an angle theta. Coefficient of limiting friction between the surface of the block and the fixed surface is mu. And we need to find out the value of the minimum force. What is the value of F minimum to slide the body over the surface? Correct? Clear? So let me solve this problem this way. Let us divide this force into two components. Okay, this is equal to F cos theta and this is equal to F sin theta. And other forces which are acting on the body are the normal reaction and width weight around this line. So this is mg and this is normal reaction. So frictional force will be act along this direction, and this is the limiting friction. Okay. In this case, F stands for limiting friction. F stands for Fs maximum. Because in this case, the question is asked ki minimum force required to move the body over the surface. Now, if I take the equilibrium along y-axis, what would be the value? So what we can write? N plus F sin theta is equal to mg. Therefore, N equal to mg minus F sin theta. Number one is this. Number two, look at this. F cos theta must be equal to F. And F cos theta equal to F. F cos theta is equal to mu into normal reaction. And F cos theta is equal to, therefore, mu into normal reaction means mg minus of F sin 30. So if we calculate this, F cos theta plus mu sin theta equal to mu mg. Therefore, F equal to mu mg cos theta plus mu sine theta. But here we need to find out the minimum value of f. Now look at this, friends. F is minimum. F will be minimum if its denominator would be maximum. Correct? So if I consider this denominator as x, clear? So we need to find out for maximum, minimum. Either it is a case of maxima or minima. First derivative is always equal to 0. So if I do differentiate it, dx d theta is equal to minus sine theta plus mu cos theta, which is equal to 0. So tan theta is equal to mu, or theta is equal to tan inverse of mu. Now, if I draw a triangle related to this, if I take this as theta and tan theta is equal to mu, which is equal to height by base, so this is mu, this is 1, and this is equal to 1 plus mu square. So what is the value of x max? Cos theta is equal to base by hypotenuse plus mu sine theta, and sine theta is equal to height by hypotenuse, so this would be mu square root over of 1 plus mu square. This would be equal to 1 plus mu square by this. So we calculate further, this will get 1 plus mu square. So what is the value of f minimum? Is equal to mu mg divided by root over of 1 plus mu square. So this is the lecture related to force of friction, how to find out force of friction. In the next video, I am going to tell you how to calculate the frictional force when string and block both are present. Thank you.